Okay, let's look at some maximum and minimum values. We're going to call them extremes, or sometimes they're called extrema. Essentially here, that's plural by the way, the absolute maximum is basically just the highest value or the biggest value on the graph. That's what absolute maximum is. Sometimes there isn't one because it goes to infinity. And again, we're referring to the function here, the actual function, not the x values. So we're only looking at the f of x values here because we're talking about the function. So we're just, if there's a, so if there's a function here that goes incredibly high here and it goes all the way to infinity, it wouldn't have a maximum. Same thing with the minimum. It's the lowest value or the smallest value on the graph that it can be. The relative maximum are kind of when you get these little humps, and it's kind of like in between. You'll notice that there's a place where it kind of levels off and it changes. And it's a relative maximum is where any place on either side is actually lower. In other words, they're not higher than that value. Okay, so I'll just show you here an example here. Same with relative minimum. Let's take a look at this example here though. If you look at this whole graph as a whole, you'll notice right here it's the lowest it can go. And the lowest it can go we're going to call the absolute minimum. If you follow the graph here, well, the highest value here is right here. And we're going to call that value the absolute max. Now everywhere else, there's a stage here where, like right here, at this point right here, on the left side it's lower, and on the right side it's lower. And so because of that, this is the highest value, and its boundary is lower on either side. So we're going to call that a relative max. We can also call this relative minimum. Excuse me. We can call this a relative minimum because the values are higher on both sides, and so this would be a relative minimum. And again, this is an absolute max because it's the highest. And over here, we can call this a relative min because it's the lowest on that portion of it, but it's not the absolute. So again, when you look at these ones here, if this graph ends right here, we can have an absolute maximum right here. We'd say the absolute maximum is 7. That's the f of x at x equals -4. That's how we write it. And we can also say that the minimum is right here, which is -3 at x equals 1. Over here, if you look at this graph here on the right side, you'll notice here that you have an absolute max right here, you have an absolute minimum right here, and you got a relative max, relative min, and another relative minimum. So you got several of them kind of illustrated there. Same thing over here. You're going to have an absolute maximum at this point, and there is no minimum because it keeps going on forever. This one here has no absolute maximum. Its absolute minimum is right here, and it has a relative max and a relative min. And notice how I write these up. And last but not least, this one here, while it does have an asymptote and it gets closer and closer and closer, I don't know if it's getting down to 1, but because of that, it basically just keeps going on forever. So we're going to say here it has no absolute maximum, no absolute minimum, and that's how we kind of work with this one here in terms of spotting those.